Welcome back to the deep dive. Today we are uh, grabbing our wrenches, putting on our coveralls, and heading straight into the basement.
Metaphorically speaking, of course. Though, I mean, with some legacy code bases I've seen, a hazmat suit might actually be appropriate.
Too true. We are talking about software plumbing. It's a term that, it really doesn't get enough love. Everyone wants to talk about the shiny new framework or the huge AI model in the back end.
Or the beautiful UI animations, yeah.
Exactly. But nobody wants to talk about the pipes connecting everything until, the basement floods.
And when the basement floods in software, it usually looks like an unhandled exception, a crash, a blank screen that won't tell you what went wrong. It's the unglamorous but critical work.
And our guide for today's plumbing expedition is a familiar name to anyone who follows Haskell over at qianmeng.org. We're looking at a specific post from January 30th, 2026, called Notes on Haskell Programming, Part 45.
Part 45? I mean, that number alone tells you something. Haskell isn't a weekend boot camp language. It's a discipline. And Eng calls himself an old software plumber. And this post is just a perfect example of that. It's not a big new feature. It's about tightening one loose bolt.
So the project is called XS2 ebook. Just to set the stage, what is that?
It's a CLI tool, a command line interface. It's designed to convert Chinese text novels into ebooks.
Okay, that sounds pretty niche.
It is, I'll grant you. But the problem he's solving is universal. It's all about application robustness. It's, what happens when a user runs your program but forgets to tell it what to do.
Right. So our mission for this deep dive is actually really specific, but it opens up this huge theoretical can of worms. We're going to look at a single line of code. We're going to see how changing one word flips a program from broken to resilient.
But then, and this is the really interesting part, we're going to fall down a rabbit hole about context.
Context, it sounds so philosophical.
It does, but in Haskell, context is a rigid mathematical concept. And if you ignore it, the compiler will literally stop you in your tracks.
So let's start with the leak.
Yeah.
What was actually wrong with XS2 ebook?
Okay, so to get the leak, you have to understand the library he's using. It's called opt-parse applicative.
Catchy name.
It's a mouthful, yeah, but it's the gold standard in Haskell for building command line tools. You know when you type git, commit, and add help?
Sure.
Something has to parse that text and turn it into instructions. That's what this library does.
So the program's receptionist. It takes the user's input and directs traffic.
That's a great way to put it. And in the previous version of Eng's code, he had defined the main parser with a setting that was simply parser empty.
Parser empty. Okay. To me, empty sounds like a blank slate, ready for input. It sounds passive, like it's waiting.
That's a very human interpretation. But we're in the world of type theory now, and in that logic, empty doesn't mean ready, it means impossible. Yeah, it represents the identity element for failure. It means no valid parse exists. So the program starts, the parser kicks in, it sees empty, and it just throws its hands up and says, I can't do this, there's no path forward, I am designed to fail right here.
So if a user just runs the command XS2 ebook with nothing else?
It crashes immediately. Exits with an error code.
Wow, that's aggressive.
It's brittle. And it gets worse because empty is a total failure. It even breaks the help system. If you type help, which is the universal cry for assistance,
right,
the program hits that empty definition, triggers an exception, and crashes before it can even print the help text.
That is a terrible user experience. It's like walking up to an info desk asking for help, and the receptionist just shuts down the building.
Essentially, yes. It's bad plumbing. It's a pipe that just bursts the second you turn on the water.
So Eng decides to fix this. In the post, he details a change to one file, srcxs2 ebook cli.js. He deletes parser empty.
And he replaces it with parser pure return.
Pure return. Okay, this looks like a stutter. You have pure and you have return. In most languages, don't those kind of mean the same thing?
They're very similar in Haskell, too, historically. Return is for monads, pure is for applicatives. But here, he's using them to handle two different layers of the problem.
Layers. Like an onion.
Exactly like an onion.
Right.
The outer layer is the parser itself. The opt-parse applicative library, it needs to know, did the parsing succeed?
Oh.
Pure is the instruction that says, yes, success. It lifts a value into that parser context without needing any input from the user. It just says, I'm satisfied right now.
So pure is what stops the crash. It tells the parser not to panic if there's no input.
Precisely. It tells the receptionist, hey, if nobody says anything, that's fine. Don't sound the alarm. But then the parser has to hand something over to the main program. It has to say, okay, I succeeded. Here's what you should do now.
And that's the inner layer.
Right. And the program is expecting an action. In Haskell, that's an I/O action.
Yeah.
Return creates an I/O action that does absolutely nothing.
So pure tells the parser, we're good, and return tells the program, now do nothing.
You got it. It's a unit value, often called unit. It's just this little bubble of nothingness that passes safely through the pipes.
This feels like a lot of heavy lifting just to get the program to sit still and wait.
That's Haskell for you. You have to be explicit. But look at the result. Now you run the program with no arguments, and instead of exploding, it just does nothing. It waits. And this lets all the other machinery, like the help flag, actually work.
It's graceful degradation.
Exactly. It turns a fatal error into a neutral state.
Okay, so that's the fix. Plumbing repaired.
Yeah.
But this is where the blog post takes that turn. Ang mentions that while figuring this out, he ran into a mystery.
Yes. The classic works on my machine mystery, or in this case, works in my terminal.
We've all been there. You type something into the interactive shell, it works fine. You paste the exact same code into a file, hit compile, and it all breaks.
And in Haskell, this isn't just a quirk, it's a fundamental lesson. It's about how the compiler thinks versus how the interpreter thinks.
So let's walk through it. He opens GHCI, the interactive Haskell environment, the REPL,
Right.
and he types in pure 5.
Simple enough.
And the terminal just prints 5.
Success. Looks easy.
Then he puts the same code in a file, foo.hs. He writes foo do pure 5. He tries to compile it. And what happens?
The compiler just screams at him.
Not a warning. A hard error.
Ambiguous type variable.
Why? Why does the terminal know what to do, but the file has no clue?
Because the terminal's trying to be your friend and the compiler's trying to be your lawyer.
Okay, explain that one.
When you're in GHCI, you're usually just trying to test something quickly. So you type pure 5. The environment looks at that and it thinks, okay, pure means wrap this value in a context. But which one?
Because pure is polymorphic, it works on lots of things.
Exactly. Pure 5 in a list context would be a list with 5 in it. Pure 5 in a maybe context would be just 5. It could be either I/O, reader, state.
So it could mean a dozen different things depending on the container you want.
Hundreds, yeah. Anything that's an applicative. But the interactive terminal has this feature called extended defaulting. It just assumes, well, you probably want to print this to the screen, so you probably mean the I/O context.
It guesses.
It guesses I/O. It treats it as an I/O action that produces the number 5, and then it runs it for you. So you see 5.
With the source file compiler?
That has extended defaulting turned off. The compiler looks at foo, pure 5, and says, nope, I see you want an applicative. I see you have an integer, but I have no idea which box you want to put this integer in.
It refuses to guess.
It explicitly refuses. It even lists the options. The error message Ang shares is amazing. It says something like, the constraint applicative at 0 could be I/O, maybe read P. It lists them out and says, pick one. I am not moving until you tell me which one.
So this is that context rabbit hole. In the terminal, the context is implied. In the code, it has to be explicit.
And that's why Haskell has this reputation for being tough, but also bulletproof. You can't write code that sort of works by accident. You have to declare your intentions.
So how did he fix this in the actual CLI code?
He had to add a type signature. He couldn't just write parser return. He had to explicitly annotate it. Parser info, I/O.
That I/O at the end.
That's the contract. That tells the compiler, when I use pure here, I am building an I/O action that does nothing. Once that's there, the ambiguity is gone. The compiler is happy.
It's so interesting in, say, Python or JavaScript.
Yeah.
Context is usually global. You don't have to stop and say, I am now existing in an input-output state.
Right. Side effects like printing can happen anywhere in those languages. In Haskell, they are quarantined. You need a permit to do I/O, and that type signature is your permit.
Okay, so we've fixed the crash. We've satisfied the compiler by being explicit. Now for the part that separates the hobbyists from the engineers, verification.
Trust but verify.
Ang updates his test file, testspec.hs. I want to dig into this because testing a CLI tool is, well, it's weird. You're testing the very edge of the program.
It is tricky, yeah. You're testing the interface itself, not just a function inside.
There are two key tests. Let's start with the first one, the help flag.
Right. This is testing the exact scenario that used to crash. Does x2buck help actually help?
The test uses a function, xParserPure. There's that word pure again.
It's a theme. xParserPure is a testing utility from the library. It lets you run the parser logic in a sandbox without it reading from the real operating system arguments.
So it simulates the program running.
Yes. And then Ang checks the output. But he's not checking for success. He's actually inspecting the failure message.
Wait, failure? I thought we wanted it to succeed.
It's a quirk of how the library works. Requesting help is technically a parser failure.
A failure? How?
Because you didn't provide the arguments to actually run the conversion, you asked for the manual instead. So the library returns a special kind of failure that just happens to contain the help text.
Ah, I see. So the test grabs that failure text and looks for keywords inside it.
Exactly. It looks for usage, access to ebook, it looks for show this help text, and it looks for the program's description.
And by finding those strings, we prove that the help system is wired up correctly and that empty isn't blocking the pipes anymore.
Precisely. The water is flowing to the right spigot.
Okay, now for the second test. The one that really proves our main fix works. The no arguments scenario.
This one is cool because of how it mocks the environment. The helper function is called withArgs.
withArgs. Sounds like it's setting the stage.
It is. The main parsing function, exec parser, is nosy. It looks at the system environment to see what you literally typed in your terminal.
But we don't want it to see stack test or whatever we used to run the test.
Yeah.
We want it to see nothing.
We want a blank slate. So withArgs temporarily swaps out the real system arguments for a list you provide.
It gaslights the program.
Yeah, it effectively does.
Yeah.
withArgs, with an empty list, tells the program, trust me, the user typed absolutely nothing.
And then inside that fake environment, we run the parser.
And the expectation is, should be,
A unit value.
which asserts that the program returned that do nothing value. It didn't throw an exception, it didn't crash, it successfully computed nothing.
It's so satisfying, isn't it? Writing a test that says, I predict nothing bad will happen, and getting a green check mark.
It is the definition of stability, and it's so important because he's taking something messy, a global system environment, and turning it into a clean, deterministic test.
So, to recap this whole journey, we started with a brittle tool, XS2 ebook. That would crash if you just looked at it wrong because of parser empty.
And we learned empty wasn't a blank slate, it was a guaranteed dead end,
We replaced it with parser pure return.
which uses the applicative context to guarantee success and the IO context to perform a safe do-nothing action.
We then got yelled at by the compiler and learned that source code requires explicit context signatures, unlike the helpful guessing terminal.
Parser info, IO. That's your permit, never forget it.
And finally, we locked it all in with tests that mock the real world using withArgs, proving our fix works in practice, not just in theory.
It's a complete loop. Problem, theory, fix, and verification.
It really hammers home that software plumbing idea. Ang didn't add a new feature. He didn't make the conversion faster. He just stopped a pipe from leaking when the pressure was low.
And that's often the difference between code that works and software that lasts. The user will never notice that the crash didn't happen. They won't write a review saying, 5 stars, it didn't segfault when I forgot an argument.
Good plumbing is invisible. You only notice it when it breaks.
Exactly.
He signs off the post with, yours truly, Ang. It's a nice touch. Reminds you that behind all this type theory, there's just a person trying to make their tool a little bit better.
And sharing the struggle, that's so important. Writing down that ambiguous type variable problem helps the next person who hits that same wall. It turns a frustrating afternoon into a lesson for the whole community.
Absolutely. Before we wrap up, I want to circle back to that idea of context.
Mhm.
In Haskell, if you don't define your context, are we in I.O.? Are we in... Maybe. The compiler stops you.
It forces you to be intentional. You have to know where you're standing.
It forces you to be explicit. And I think there's a broader lesson there for you listening, in your own problem solving, whether it's coding in Python, managing a team, whatever. How often do failures happen just because the context wasn't defined?
That's a huge question. We often assume everyone knows we're in emergency mode or brainstorming mode, just like GHCI assumes we're in IO mode.
Exactly. We rely on extended defaulting in human communication. We assume the other person knows what context we're in. But unless you make it explicit, you're going to get an ambiguous type error.
Or a misunderstanding with your boss.
Or a crashing application.
And the application crashes are usually easier to debug.
Ain't that the truth? Ang's post is a great reminder that sometimes the most important work is just defining the rules of the game so everyone knows how to play.
Couldn't have said it better myself.
That's it for this deep dive into XS2 ebook and the world of Haskell plumbing. Thanks to Ang for the detailed notes. You can check out the show notes for a link to the original post.
And keep an eye on those type signatures.
Always. Thanks for listening, and we'll catch you on the next deep dive.